Alright guys, this video is a review of oxidation state. Here these are the criteria that I need you to follow. Okay, we discussed this topic in Chem 1. Take a look at the first one. Each atom in free elements has an oxidation state of 0. Examples here are zinc, oxygen gas, iodide, phosphorus, and the sulfur elements. And more example, nitrogen and chlorine gas, because these are the free element, they are neutral, so oxidation states for all of them are 0. Number 2, in simple ions, oxidation state equals to the charge on ion. The simple ions means there is only one element in this ion. For instance, lithium. Okay, the charge for lithium cation here is 1 plus. Okay, so oxidation state for lithium is positive 1. Usually we just we can label the oxidation states of the elements on the top of the sign. Okay, positive 1 is the oxidation state. And iron 3 plus. 3 plus is a charge. Okay, and so because it has only one element, oxidation state for iron is positive 3. Okay, so here I want you to know the difference between the charge and oxidation state. And the charge usually is the number on the upper right corner of this formula. And the charge, we label that on the top of the sign. Okay, positive 3 is the oxidation state, 3 plus is the charge. Sulfide, 2 minus is the charge, because again it has only one element, so the oxidation state is negative 2. Okay, negative 2 here. Some other examples like chloride, so oxidation state is negative 1. Okay, charge is 1 negative, so that's and magnesium 2 plus. 2 plus is the charge, so the oxidation state is positive 2. Okay, so this is number 2. Number 3, oxide usually has an oxidation state of negative 2. We do have some exceptions like hydrogen peroxide. In this case, oxygen is negative 1. Okay, but in most of oxides, oxidation state for oxygen is negative 2. For instance, manganese oxide. Okay, the oxidation state for oxygen is negative 2, and something like sodium oxide, again negative 2. Okay, and later on when we discuss number 6, you will see that based on what we have here, we can calculate the oxidation state of the manganese and the sodium. Okay, we will come back to these 2 examples later on. Hydrogen cation usually, for instance, oxidation state would be positive 1, like water. Okay, water here, oxidation state for oxide is negative 2, and oxidation state for proton here is positive 1. So the charge is balanced. All right. But we do have some exceptions like hydride. Hydride, for instance, sodium hydride. Okay, because sodium has only one possible oxidation state, that is positive 1. So in this case, hydrogen would be negative 1. All right, so this is hydride. Number 4, fluoride is always negative 1. It's always like this. Okay, fluoride is so selfish. It has such a high electron negativity. It always want to get electrons from other elements, so it's always negative 1. Other halogens usually are negative 1. Okay, so let's see fluoride first. Fluoride, let me give you one example, like a bromine trifluoride. In this case, fluoride is negative 1. Okay, and sodium chloride, we know this compound very well. Chloride oxidation state is negative 1. Okay, but sometimes chloride and chlorine, bromine, and iodine, they could have a positive oxidation state. Okay, we will learn how to identify them later on in this video. Number 5, group 1A metal is always positive 1, group 2A metals are always positive 2. Examples include the lithium plus, okay, oxidation state is positive 1, sodium plus, oxidation state is positive 1, potassium plus, oxidation state positive 1, okay? So group 2A, like the magnesium 2 plus, all right, 2 plus, and calcium 2 plus, okay, and some other strontium, that is a 2 plus. Okay, so those group 2A metals, they have only one possible oxidation state. That is positive 2. All right, number 6. If you add the oxidation states of the elements together, okay, it equals to 0 if the compound if the charge of this compound is neutral. It could equals to the overall charge if you are talking about an ion. Let's use a specific example to explain this. Let's take a look at this Cr2O7 2 minus. What does that mean? Okay, if you are using number 6. Remember, this is the oxide here. Okay, so the charge is negative. The oxidation state for oxygen is negative 2. Now, so this we are talking about ion here. So when you add the oxidation states of those two elements together, that should equal to the 2 negative charge of this ion. So if you want to know the oxidation state of the chromium, then let's just put a question mark on the top of the chromium side to represent oxidation state of the chromium. And you have 2 chromium in this ion, so multiplied by 2 plus the sum, okay, plus the negative 2 for each oxygen, and you have 7 oxygen in this ion. Okay, so you add all of them together, that equals to the negative 2. Where does that negative 2 come from? It comes from the charge of this ion. So we are using this overall charge criteria here. And if you do the calculation, the question mark, which is the oxidation state for chromium, that should be 6, okay, positive 6. All right, so this is how we calculate the oxidation state based on the number 6. And then let's take a look at this manganese oxide. Okay, we know the oxidation state for oxygen is negative 2. And if we want to know the oxidation state for manganese, then we set up the question mark. Okay, you only have one manganese, so question mark times 2, negative 2, which is the oxidation state for oxide, times 2. You have 2 oxide. That equals to 0. Why it's 0? Because the whole compound is neutral. There's no charge, so it's 0. And if you do the calculation, the question mark oxidation state for manganese is positive 4. All right, for sodium oxide, again, oxide negative 2, question mark oxidation state for sodium, question mark times 2, you have 2 sodium in this compound, plus, okay, plus negative 2 from oxygen should be equals to 0. Again, because the whole compound is neutral, so there is no charge, so it tells us the question mark oxidation state for sodium is positive 1. All right, so this is how we use I can give you one more example of perchlorate. Perchlorate, in the criteria number 4, other halogens usually are negative 1. Chloride, sodium chloride, has a negative 1 positive oxidation state. But here, if you want to identify the oxidation state for chlorine here, then we use the strategy we just discussed. Oxide, usually it's negative 2, so question mark for chlorine, question mark plus negative 2, oxidation state from oxide times 4 4 oxygens equals to -1. Okay, where does that -1 come from? It's come from the charge of the ion. If you do the calculation of the question mark, that would be +7. Okay, so now we know that chlorine, bromine, and iodide, they could be positive. They could have a positive oxidation state. All right, I hope this video can help you refresh your memory about the oxidation states. Please do more practice and let me know if you have any questions.